Hello everyone, welcome to Reactive Labs. Today we will do another Leetcode problem, minimum number of operations to move all balls to each box. You might be wondering why I didn't write the full name here. The reason is that there is a character limit for this section and it did not allow me to write the entire question. So that's why I wrote it here. Okay, this is the first time I have ever done this. So let's jump into the problem description. So this is the question number 69 and it is also a medium difficulty problem. Okay. So the problem statement says, you might have figured out from this one, but let me tell you what exactly the statement is. You have n boxes. Okay. So you have n boxes. And you are given a binary string. Okay, so you have a binary string which is called boxes. Okay, it's a string. Okay, it has length n, which is same as this n. Okay, and it's a binary, so it means it is a combination of 0 and 1. Okay, and it says that 1, it means when, let's say example is 110, so 1 represents, and first of all this represents, you have 3 boxes. 1 represents there is a ball, 0 represents the box is empty. Okay, and also it's binary, the string is binary, it means it can have only zeros and ones. Okay, no 2, 3, anything. Okay, only 0 and 1, and it means the box can only have one ball or no ball. Okay, and no ball means free hit. Yeah, sorry about that. And your question is, the problem statement is that you have the boxes, right? And in one operation, right, you have to give the minimum number of operations. So in one operation, you can move one ball only to its adjacent box. Okay, like you cannot move this ball directly here. To move this ball to this point, you have to do first this and then this, right? So that's why it will require 2 operations to move this ball from here to here. Okay. Similarly, it will require 1 operation to move this ball here. So it says that you have to count how many number of operations, minimum number of operations will be required to move all the balls to each box. So for example, to move all the balls to this box, you have to move only this ball from here to here, right? So only 1 operation will be required. To move all the balls to this box, you will only need to move this ball here, and so it will also require 1. To move all the balls to this box, you will need to move this ball here, which will take 1 operation, right? This ball here and then this ball here, so which will be 2 operations and then 1 operation, which is 3 operations. So 3 operations. So for this, the answer is 1, 1, 3. Okay, so you have to return the answer in the form of array. That's why I have written it like this, and you are given a string. Okay, if the question demanded that you have to return it as a string also, so we would have returned this now in that case. Okay, so that's it. That's the problem statement. Let's understand with another example. So 0, 0, 1, 1, 0, 0, 1, 0, 1, 1. So if you see, if we have to move all the boxes here, we will need how many? 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5. So 2 plus 4 plus 5, which is 11. So you need 11 operations to move all the balls to this box. Okay, so for this box the answer is 11. Similarly, for this box the answer would be 1, 1, 2, 3 and 1, 2, 3, 4. So total 8. Okay, 11, 8. Similarly, for others it will be 11, 8, 5, 4, 3, 4. So this will be our answer. Okay, that's it. So now it says, now we know, okay, we know that how to count. So let's say how we can derive or how we can solve this question. Okay, like we cannot just keep on counting for everything, right? If you just, let's say for example, for this one, for let's say here, you have to move 1 here, 2 here. So basically it will be for each of these you have to move all the n times. So for all n you have to consider all the n of these, right? So it will be n square. Now let's talk about the constraints. Will this constraint allow us to do an n square? So it says the value of n can be between 1 and 2000. So it proves that our n square solution will work because it will be 4 into 10 to the power 6. So it will work. But can we optimize it? Can we do better? It will work, yeah, but you are not expected to use that, right? The interviewer might ask you, can you optimize it if you wrote an n square solution? And that person is expecting, because you are an engineer, you should not just be able to write code, you should be able to solve problems, okay? And solve problems in the most optimized manner, okay? So that's why let's see what the optimal way should be. So if you see 0 0 1 0 1 1, so 0 0 1 0 1 1, okay? So if you see for every index, so for example, let's say this index, we need to find out how many balls will come from this end and how many balls will come from this end. Similarly, for this index, we will have to find how many balls will come from this end, how many balls will come from this end. So if you see, if we take it as a string, because we are taking it as a string, we are given a string. So we have, if you see, left side as prefix and right side as suffix, okay? So if we can find a relation between prefix and suffix to the actual answers, we can solve this problem, right? So let's see what we can do. So for example, for this, if you see, the prefix, let's name it prefix, okay? And let's name it suffix, okay? So prefix means how many balls before this point, okay? So it means because since this is 0, it will be 0, nothing. For this, if you see, how many balls are coming from the left of it, if you see. So no ball is coming from left of it, it's 0. How many balls are coming from the right or from the left of it? 1 ball is coming from the left of it, right? That's how it works. Now here, if you see, again, it will be asked how many balls are coming from the left of it. So if you see, only 1 ball is coming from the left of it. But how many steps is this ball taking, right? So how many moves, basically, how many moves or operations are coming from the left of it? There are 2, right? And for this one, if you see, how many are coming from the left of it? So 1 is coming from here and 1, 2, 3 is coming from here. So basically 4 is coming from the left of it, right? 1 and 1, 2, 3. But how do we know? We cannot just keep on counting, right? So for that, what we will do is we will have a variable called count, okay? And the count variable will be updated after every move. So if we have count, okay, so initially we'll see we are at this point, so the count will be 0, nothing, okay? And prefix will be 0 because it's 0. Here also it's 0 because that's intuition, right? It's nothing is coming. So I'll tell you how to do the calculation. So since we have witnessed 1 here, okay, we have witnessed 1 here, so we will see how much is it till this point, okay? How much the value is till this point, okay? Prefix of I minus 1 plus what is the value of count. So prefix I is equal to prefix I minus 1 plus count, okay? So for this also it will be 0. And after this is done, then we will update count equal to, actually count plus if prefix I or the boxes I, if boxes I is 1. If it is 1, only then, otherwise 0. So since it is 1, so our count will change to 1 now, okay? Now here it will be, what is the value till this point? 0 plus count, so it will be 1, okay? And again, it is 0 now, boxes I is 0, so the count will not change. So we move here. So when we move to this point, if you see, we know that prefix I minus 1 is 1 and count is 1, so it will be 2, okay? And since it is 1, so this condition will be true and the count will be 2 now, okay? So now we move to this point. Prefix I minus 1 is what? 2, right? Prefix I minus 1 is 2 and count is also 2, so this will be 4, okay? It's done. Similarly, the same thing we will do for suffix now. So what we are going to do is, for suffix, what we will do is, again, the count will start from 0, but if you see this value is 1, so the count will be 1, okay? The count will be 1. And same thing, suffix of I will be suffix of I plus 1, okay? Because we will be going in this direction, so this one will be filled by this one, okay? So suffix I plus 1 plus count. Okay. So for this one, the count is 1 and by default this will be 0 because this is intuition. You see, at this point, nothing is coming from the right of it, right? Everything, like all the balls need to come from the left of it. So the suffix will automatically be 0. So we will not consider this. So we'll move from here. Okay. Now see, suffix I is what? Suffix I plus 1 plus count. So count is 1. So it will be 1. And since it is 1 now, so the count will increase to 2. Okay. Now here if you see, so suffix I plus 1 is what? 1. Suffix I plus 1 is 1 plus count, and count is 2. So it will be 3 now. And since it is 0 and again the count will be count plus plus only if boxes I is 1. Since it is 0, the count will not change. Now we are at this point, right? So if you see, suffix I plus 1 plus count. So 3 plus 2 is 5, correct? And since it is 1, so the count will also increase to 3. Now we come to this point. So it is suffix I equal to suffix I plus 1 plus count. It means 8 because 5 plus count, this 5 plus this count, 5 plus 3, 8. And since it is 0, the count will not change. Again, when we come to this point, we will see that suffix I plus 1 is 8 and count is 3. So 8 plus 3, 11. So it's 11. So our final answer will be the summation of suffix and prefix, which will be 11, 8, 5, 4, 3, 4. If you see, it matches our answer. Okay. So that's how it goes. Okay. Let's quickly reiterate it. I don't know if you followed it really well, but let's try it again. 0, 0, 1, 0, 1, 1. Okay. So we have only 4 variables. If you see, actually let me give it some space. 0, 0, 1, 0, 1, 1. So we will have a count p. I know count is a variable, but just for explanation, just for visualization, I am doing it like this. Count p, count s. Let's consider it's an array, like it's just little extra space. We can optimize. We have optimized it on there, but to visualize, I am doing it like this. Okay. Prefix, suffix. Okay. So by default prefix is 0 for the first one. By default suffix is 0 for the last one. Count, if you see, count at this point is 0. This is also 0. At this point, the count will be 1. But remember, count is incremented after the calculation. So the count at this, so when we calculate this prefix, so the previous count is used. Okay. So for this one, this count is used. Okay. So this is 1. The count will keep on same. This, since this is 1, only then the count will change. So this is count 2, this is count 3. Okay. When we are coming back, since this is 1, the count will be 1. This is 1, count will be 2, count will be 2, count will be 3 and 3 and 3. Okay. As we can see, only 3 ones are there. So the maximum value of count can be 3. Now, what we are doing? Prefix plus 1 plus count. So if you see here, it will be this 0 plus this count. Okay. So it's 0. Now this 0 plus this count. 0. This 0 plus this count. 1. For this point, this 1 plus this count. Again 1. This 1 plus this count. 3. Right. Similarly, for this one, this 0 plus this count, suffix count. So it will be 1. For this point, this 1 plus this count, which is 3. Now this 3 plus this count, which is 5. This 5 plus this count, which is 8. And then this 8 plus this count, which is 11. And then once we have this, we will just add them. 11, 8, 5, 4, 2. Actually, why is it 2? It should be 3, right? This 1 plus this 1 I said, right? So this should be 2. So this is 3. And actually, this is 0, right? And this should be 2 plus 2. I don't know why I made that mistake. 2 plus 2. So this should be 4. So this is 4. Okay. So that's how it is solved. I hope you understood it. It's like, it's a medium level problem. Yes. And it's like, you just have to get the idea that if you have to do some calculations multiple times, you can optimize it by doing prefix and suffix. and so that's how it will save you a lot of time. Okay, so now this problem has reduced to order of n complexity, time complexity, rather than order of n square. Okay, and yes, there is earlier when it was order of n square, if you had to do only the iterations, there was order of one space, but now if you see, you have used two extra spaces, like 2 on, so it means order of n space, on time and on space is there. TC, SC, this is also TC, this is SC. This is for old one, this is for the new one. Okay, so this is the time and space complexity. I hope you find this video helpful. If you didn't understand any part of it, please let me know in comments. I'll try to make another very detailed video on this of many hours long if it is required. Please let me know. Okay, yeah, that's all. Thank you very much. Have a nice day, and please remember to like, share and subscribe, and I'll see you in the next one.